5.1's about polynomial functions. This is a table of how you name them based on degree and based on number of terms. So just for example, if you use number 5, that's what we call a constant monomial. Okay, how about x plus 4? Well, it's a linear because the highest degree is 1, and it's a binomial because there's 2 terms. And we'll go through and copy the chart down, and we'll talk about this as we work through. It's really the same thing as we go. Anything bigger than 3 terms, which we call a trinomial, we'll call a polynomial of x amount of terms, however many terms they have in it. So standard form, pretty simple, write it from biggest exponent to smallest. So 9x squared plus 3x plus 5. And what's classification of each polynomial? Should be a squared, I'm sorry. That, because of the squared term, is a quadratic. And then 3 terms is a trinomial. Okay, again, standard form, biggest exponent, x to the 4th. They kind of throw some at you because it's negative 6x squared and 10x squared, but that's the next biggest exponent, so I'm just going to combine like terms, and you end up with plus 4x squared plus 4x minus 12. What do I have? Well, we have a 4th term, that's a quartic, and it's got more than 3 terms, so it's a polynomial. Now, with 4 terms, it is what it is. If you don't want to say it, that's fine. There's certain characteristics of polynomials here that we're going to focus on, and it's the end behavior of these graphs, and like what is happening as these graphs going up, are they going down, what are they doing? So the simple thing is this table right here where it talks about if n is even and a is positive, it goes up and up. So if you look at the first one, a is 4, okay, it's positive, so we know it's at least it's up there, okay, or something like that, and it's even, okay, that 4 is even. Erase that so you can see it. That 4 is even, so even and positive, it's up, up. Notice the ends of the graph are up and up. Okay, if we look here, a is negative, so we go down to this one, it's an even exponent, so what does that mean? Down, down. Okay, if we look here, y equals x cubed, well, now we're in this n is odd. Okay, well, is a positive or negative? Well, a is positive, so what is it? It starts down and then goes up. So where's it start? Where's it end? Up, up, down, down, up, down. So problem 2 is talking about describing the end behavior. Consider the leading term of the polynomial function was the end behavior of the graph. Okay, now check your answer with the graph calculator. Personally, I would just plug all this in my calculator so you don't really have to remember anything and just watch it, draw it, and you can see where it's coming from and where it's going to. That's the easiest way to do this stuff. But again, if we're going by hand, you look at the a, which is the 4, and this is odd. Okay, so we have positive and odd, so we're going to go down, up. Okay, now, what's the biggest term here? Well, now we have even and negative. So go to my little chart, a negative, even, down, down. Again, like I said, I would plug this in my calculator and just see how it draws it. I'm going to try to find the degree of the polynomial just based on a graph or the coordinates of it. And so what I need to know is what all the y values are. So notice I've listed all my y values. And look at the table. List all my y values. I want to do the first difference. So it goes from bottom up. So negative 7 minus negative 1. Okay, is really negative 7 plus 1, which gives me negative 6. Okay, then we do this one. Negative 3 minus negative 7, which is positive 4. This one, 5 minus negative 3, which is 8. Now this one, 11 minus 5 is 6. 9 minus 11 is negative 2. And negative 7 minus 9 is negative 16. Okay, so you want to go always second minus first here. So same principle here. Second difference, 4 minus a negative 6 is positive 10. 8 minus 4 is 4. 6 minus 8 is negative 2. Now these two, negative 2 minus 6 is negative 8. And now these two, negative 16 minus negative 2 is negative 14. Okay, so now these are not all the same. We're looking for these to be the same. So let's do it again. The third difference. So 4 minus 10, negative 6. Negative 2 minus 4, negative 6. Negative 8 minus a negative 2, negative 6. Negative 14 minus a negative 8, negative 6. Notice how these are all the same now? Okay, since they're all the same, the degree of the polynomial is 3. Why? Because it took the first difference, I subtracted the second difference, and then I subtracted the third difference. It took 3 times to subtract, so it makes it a third degree polynomial. That's it.